bottom line, I simply want to make ever better car, no matter what kind of the powertrain they have.
Toyota believes in a future that will be safer, greener, and easier for everyone.
Toyota's all-new hydrogen cars shock the entire car industry. While the automotive world rushed headlong into battery electric vehicles, Toyota quietly doubled down on a different bet: hydrogen.
Toyota is currently the only company making hydrogen in our company, and they are researching this hydrogen more than 20 years.
And now, that gamble is starting to pay off in ways that have competitors scrambling. The Japanese automaker isn't just sticking to its guns, it's unveiling hydrogen technology that addresses nearly every criticism ever leveled at fuel cell vehicles. What seemed like stubborn resistance to the EV revolution might actually be strategic brilliance that reshapes transportation as we know it. Toyota's hydrogen bet while everyone went electric.
Think about electric cars being slow and ugly and poor performance. So we want to have a sports car, a car that is fast, looks good, sexy. That's right. Haha.
When Tesla was making headlines and every major automaker announced multi-billion-dollar EV commitments, Toyota became the odd one out. The company that pioneered hybrid technology with the Prius wasn't rushing to go all in on batteries. Instead, Toyota's leadership kept insisting hydrogen had a critical role to play. Critics called them delusional. Industry analysts questioned their strategy. Even some Toyota fans worried the company was missing the boat. But Toyota wasn't being stubborn for no reason. Their engineers saw limitations in battery technology that others seemed willing to overlook. The mining impact of lithium and cobalt, the charging infrastructure challenge, the weight penalty for larger vehicles, and the performance degradation in cold weather, these weren't small problems to ignore. Toyota's executives believed that different vehicle types and use cases would require different solutions, and that hydrogen made more sense for certain applications. The company had already invested heavily in fuel cell technology through the original Mirai, launched back in 2014.
一つは CO2 排出を減らすカーボンリデュースビークル。
While sales were modest, Toyota treated it as a long-term research project, learning from real-world use and refining the technology. They understood that hydrogen infrastructure would take time to develop, much like gasoline stations didn't appear overnight when cars first replaced horses. Toyota was playing a decades-long game while others chased quarterly results and stock price jumps. This wasn't just about passenger cars either. Toyota recognized that heavy-duty trucks, buses, and commercial vehicles faced even bigger challenges with batteries due to weight and charging downtime. Hydrogen offered refueling times similar to diesel with zero emissions. The company began testing fuel cell trucks and buses, building expertise across multiple vehicle categories, while competitors focused almost exclusively on consumer EVs, the new hydrogen powertrains. Explained Toyota's latest generation fuel cell system represents a massive leap forward from earlier versions.
Fuel cell electric powertrains are unique in that they generate their own electricity using hydrogen as a fuel. This is achieved via a fuel cell stack.
The new powertrain is smaller, lighter, more powerful, and significantly cheaper to produce. The fuel cell stack itself has been reduced in size by about 20%, while actually increasing power output. This improvement comes from better catalyst materials that use less platinum, one of the most expensive components in fuel cell construction. The system works by combining hydrogen from the tank with oxygen from the air to create electricity, with water vapor as the only emission. But the devil is in the details, and Toyota's engineers have refined every aspect. The new membrane electrode assemblies are more efficient at lower temperatures, meaning the system reaches optimal performance faster after starting. The air compressor that forces oxygen into the stack has been redesigned to be quieter and more energy efficient. One breakthrough that doesn't get enough attention is the hydrogen storage system. Toyota has developed tanks that can hold hydrogen at 700 bar pressure. That's about 10,000 pounds per square inch, while meeting the strictest safety standards. These tanks use carbon fiber wrapping around a polymer liner, making them incredibly strong yet relatively lightweight. In crash tests, these tanks have proven more resilient than conventional gasoline tanks. The electric motor paired with the fuel cell has also been upgraded. Toyota borrowed technology from their battery electric development to create motors with higher power density and better thermal management. The result is a powertrain that delivers instant torque like an EV.
We can actually power an entire house. That's pretty exciting, and you can do it on clean energy with renewable hydrogen.
But with the range and refueling convenience of a gasoline car. The integration between the fuel cell, battery buffer, and motor is managed by sophisticated software that optimizes efficiency in real time based on driving conditions. What really sets this generation apart is modularity. Toyota designed the system so that multiple fuel cell stacks can be combined for larger vehicles or scaled down for smaller applications. This flexibility means the same core technology can power everything from a compact sedan to a semi-truck. The company is even exploring marine and stationary power generation applications using the same fundamental components. The Crown and Mirai, hydrogen flagships reimagined.
Today, we are at a turning point in automobile history. Four-door sedan can travel 300 miles on a single tank of hydrogen.
The second generation Mirai, launched in 2020, showed that hydrogen cars could be desirable, not just practical. Gone was the awkward styling of the original. The new Mirai featured sleek sedan proportions, a luxury interior, and driving dynamics that earned genuine praise from automotive journalists. With a range of about 400 miles and improved performance, it made a compelling case for fuel cells. But Toyota isn't stopping there. The company has announced plans to expand hydrogen powertrains across multiple models, including the Crown sedan. The Crown, already a legendary nameplate in Toyota's lineup, represents a perfect platform for showcasing refined fuel cell technology. By placing hydrogen variants alongside hybrid and plug-in hybrid versions, Toyota is offering customers genuine powertrain choice rather than forcing everyone down the same path. What's particularly interesting is how Toyota is positioning these vehicles. Rather than marketing them as eco-warrior statements, they're emphasizing the practical benefits: quick refueling, long range, smooth and quiet operation, and cold weather capability. The hydrogen Crown is being developed with the same luxury and performance expectations as any premium sedan, not as a compromise for the environmentally conscious. The next wave of hydrogen vehicles will benefit from all the cost reductions and performance improvements Toyota has achieved. Sources suggest the upcoming models will offer competitive pricing with equivalent battery electric vehicles, removing one of the biggest barriers to adoption. The company is also working on hydrogen versions of SUVs and potentially trucks, recognizing that bigger vehicles benefit even more from hydrogen's weight advantages over batteries. Toyota has been testing these vehicles extensively in real-world conditions, from the freezing winters of northern Japan to the desert heat of the Middle East. This validation process ensures that when hydrogen models reach customers, they deliver consistent performance regardless of climate. The company learned from early Mirai feedback and has addressed every common complaint in this new generation: the infrastructure problem. Toyota is solving. The biggest criticism of hydrogen vehicles has always been the lack of refueling stations. It's a classic chicken and egg problem.
One of the issues we have to solve is hydrogen stations.
Stations won't get built without cars on the road, but people won't buy cars without stations available. Toyota decided to stop waiting for someone else to solve this and started tackling it directly. In Japan, Toyota has partnered with industrial gas companies, energy providers, and even competing automakers to build out hydrogen infrastructure. The company has invested directly in station construction and helped develop standardized fueling protocols that ensure any hydrogen vehicle can use any station. This collaboration approach has been crucial in getting Japan's hydrogen network to critical mass in key urban areas. The company is also working on making the stations themselves more practical. Traditional hydrogen stations are expensive to build, costing several $1 million each. Toyota has supported development of smaller modular station designs that can be deployed more affordably in areas with lower initial demand. Some of these use on-site hydrogen generation from renewable electricity, eliminating the need for tanker truck deliveries. In California, where the majority of U.S. hydrogen vehicles operate, Toyota has been instrumental in supporting First Element Fuel and other station operators. The company provides technical expertise, financial support, and demand forecasting to help make station economics work during these early growth years. They've also worked with policymakers to secure funding and streamline permitting processes that were creating unnecessary delays. Beyond fixed stations, Toyota is exploring mobile refueling solutions for commercial fleets. A truck-mounted system could service vehicles at a depot or job site, similar to mobile diesel refueling, but with hydrogen. This approach could accelerate adoption in the commercial vehicle segment without requiring extensive fixed infrastructure immediately. Performance that rivals electric. When people think hydrogen cars, they often imagine sluggish, compromise-filled vehicles driven purely by environmental guilt. Toyota's latest hydrogen cars shatter that perception completely. The current Mirai accelerates from 0 to 60 in about 7.5 seconds, respectable for a mid-size sedan. The instant torque from the electric motor provides smooth, effortless acceleration that feels similar to a battery EV. But where hydrogen really shines is in real-world usability. While EV owners plan trips around charging stations and wait 30 minutes or more for an 80% charge, hydrogen refueling takes about 5 minutes. That's actual pumping time, similar to gasoline. You can leave on a road trip with full range, drive 400 miles, refill in minutes, and continue without the anxiety that still plagues long-distance EV travel. Cold weather performance is another area where hydrogen maintains advantages. Battery EVs can lose 30 to 40% of their range in freezing temperatures due to battery chemistry and cabin heating demands. Hydrogen fuel cells actually generate heat as a byproduct of electricity production, meaning cabin heating is essentially free and doesn't impact range. The system also starts and operates normally in sub-zero temperatures without the preconditioning delays that affect batteries. Range consistency is remarkable too. Unlike batteries that degrade over time and lose capacity, hydrogen tanks don't wear out in the same way. A 5-year-old hydrogen car will have essentially the same range as a new one, assuming the tank passes its periodic inspection. This could make hydrogen vehicles more attractive in the used car market, maintaining their utility and value better than degraded battery packs. The driving experience itself has impressed skeptics. The combination of instant electric motor torque, low center of gravity from the underfloor hydrogen tanks, and near-silent operation creates a refined, modern feel. There's no transmission shifting, no engine noise, just smooth power delivery. In many ways, it feels exactly like driving a battery EV, except you never worry about where you'll charge. The portable hydrogen cartridge revolution. Perhaps Toyota's most intriguing hydrogen innovation isn't in the cars themselves, but in how hydrogen gets stored and distributed. The company has developed a portable hydrogen cartridge system that could fundamentally change how we think about fuel. These cartridges are about the size of a large thermos, designed to be easily carried and swapped by hand. Each cartridge holds a relatively small amount of hydrogen, but that's exactly the point. Rather than requiring massive infrastructure for every application, these cartridges could be delivered, swapped, or even mailed. Toyota envisions them powering everything from small generators to mobility scooters, outdoor equipment, emergency backup power, and yes, even some smaller vehicles. The cartridges can be filled at centralized facilities and distributed through existing logistics networks. For urban environments where space is limited, this could enable hydrogen use without requiring dedicated refueling infrastructure. A convenience store could stock cartridges like propane tanks. An apartment dweller could swap cartridges for a small hydrogen-powered scooter without needing any special equipment. The applications extend far beyond transportation into decentralized energy storage and use. Toyota is developing these with safety as the absolute priority. The cartridges are designed to withstand significant impacts, extreme temperatures, and rough handling. Multiple redundant safety features prevent leaks or dangerous pressure buildup. In testing, they've proven robust enough for everyday consumer use, though regulations will need to evolve to allow widespread distribution. The genius of this approach is that it makes hydrogen accessible for applications where a full fuel cell vehicle doesn't make sense. It democratizes the technology and creates many more use cases that can justify production scale and cost reductions. As manufacturing volume increases, the cost of fuel cells drops, benefiting the automotive applications as well. It's a strategy to bootstrap the entire hydrogen ecosystem. This isn't just concept thinking either. Toyota has begun pilot programs with these cartridges in Japan, testing real-world usage patterns and gathering feedback. The company is working with regulatory bodies to establish safety standards and certification processes. If successful, portable hydrogen could become as common as batteries for certain applications. Manufacturing and cost breakthroughs. The elephant in the room for hydrogen vehicles has always been cost. Early Mirai models were expensive, with fuel cell stacks containing significant amounts of platinum and complex manufacturing processes. Toyota has attacked this problem systematically, reducing costs through better design, material science, and manufacturing scale. The amount of platinum required in the fuel cell catalyst has been reduced dramatically through better dispersion techniques and more active catalyst support materials. Toyota's engineers discovered ways to use smaller platinum particles more efficiently, reducing the total precious metal loading by about 80% compared to early designs. This single change removed thousands of dollars from the system cost. Manufacturing processes have been refined to allow higher volume production with better quality control. Toyota is applying the same lean manufacturing principles that made their combustion engine production so efficient. Automated assembly, statistical process control, and continuous improvement methods are driving down labor costs and defect rates. The company projects that at moderate production volumes, fuel cell system costs could reach parity with battery electric powertrains. The hydrogen tanks, once a major cost driver, have also seen significant improvements. New winding techniques for the carbon fiber and better resin systems have reduced both material use and manufacturing time. Toyota has partnered with suppliers to invest in dedicated high-volume tank production facilities, capturing economies of scale that weren't possible when every tank was essentially custom-made. Beyond the components themselves, Toyota is designing for serviceability and longevity. Fuel cell stacks are being engineered for longer life with predictable degradation rates, reducing total cost of ownership. Modular construction allows individual components to be replaced rather than entire systems, making repairs more affordable. The company is building out service training and parts distribution to ensure hydrogen vehicles can be maintained as conveniently as conventional cars. Why this shakes the electric vehicle dominance. Tesla and other EV makers have enjoyed relatively unchallenged dominance in the zero-emission vehicle space, at least in terms of narrative and mindshare. Battery electric became synonymous with clean transportation in most people's minds, but Toyota's hydrogen advances are forcing a recalculation of that assumption. The EV-only future is starting to look less inevitable. For larger vehicles like trucks, SUVs, and commercial vehicles, hydrogen's advantages become more pronounced. The weight penalty of batteries increases with vehicle size, while hydrogen systems scale more favorably. A hydrogen semi-truck can carry more payload and refuel faster than battery equivalents, potentially offering better economics for operators. If hydrogen succeeds in these segments, it establishes infrastructure and manufacturing scale that benefits passenger cars too. The battery supply chain is showing cracks. Lithium prices have surged, mining projects face local opposition, and geopolitical concentration of materials creates supply security concerns. Hydrogen can be produced anywhere with water and renewable electricity, offering genuine energy independence. Countries are recognizing this strategic advantage and investing accordingly in hydrogen infrastructure. Consumer choice matters too. Not everyone wants to wait for charging, even with improving fast-charging technology. Some people drive patterns and living situations make home charging impractical. Hydrogen offers these buyers a zero-emission option that fits their lifestyle without compromise. Toyota is betting that customer diversity will support multiple powertrain solutions rather than a single winner-takes-all technology. The competition responds by dismissing hydrogen as inefficient because of energy conversion losses. While technically true that direct battery charging is more efficient than producing hydrogen, this ignores the bigger system picture. Hydrogen can store seasonal renewable energy surplus, balance grid loads, and serve applications where batteries don't work well. The either-or framing misses how different technologies can complement each other in a comprehensive, clean energy system. What started as Toyota looking stubborn and out of touch is beginning to look like patient strategy paying off. The company isn't declaring hydrogen the only solution. They're proving it's a viable solution that deserves a place alongside batteries. And that challenge to EV orthodoxy is making some competitors very uncomfortable as they realize they may need to hedge their all-in battery bets. The automotive industry spent the last decade assuming one clear path forward. Toyota's hydrogen shock is forcing everyone to reconsider whether the future might be more complicated and interesting than a simple battery-powered monoculture. Whether hydrogen reaches mainstream success or remains a niche alternative, Toyota has ensured the conversation around clean transportation stays open. And sometimes, that's exactly what disrupts an industry.